Welcome to this mix on momentum in the R Dynamic Universe unit. What you need to learn from this is what is momentum, its definition, and how the momentum before a collision compares to the momentum after collision. And at the minute we're looking at collisions where the objects join together after the collision. And we're carrying out calculations for collisions where the objects start separately and then join together and move off together after the impact. So even if we're not aware of the word momentum, we come across it in our everyday life. The momentum of an object is the mass multiplied by the velocity, or the product of mass and velocity. So P is the symbol for momentum, and mass times velocity is m times v. It is a vector quantity because velocity is a vector quantity. Momentum is measured in kilograms times meter per second. The total momentum is conserved in a collision provided there are no external forces acting. This is called the law of the conservation of momentum, and you can be asked to quote it. So the momentum is conserved provided there are no external forces. It's important that you get that bit extra, the no external forces, as well as saying that momentum is conserved. So when you're solving momentum problems, drawing a diagram is key to them. So here we have an object moving to the right with a velocity, and it's object 1, so we've called it m1 and velocity 1. Here's the second object, m2, and it has a velocity of 2, and afterwards they're joining together and moving off at their own velocity. So the one on the left, the first one, is going to crash into the back of the second one, and then they stick together and move off together. The total momentum before is equal to the total momentum after, provided there are no external forces acting. In letters wise, we can say m times v, m1 v1 plus m2 v2 is the total mass m1 plus m2 times v3, the velocity of both objects joined together after the collision. So let's look at an example. A 4 kilogram mass travels at 3 meters per second and collides and sticks to a stationary 4 kilogram mass. Calculate the velocity just after the impact. So we draw a diagram. 4 kilograms to the right, 3 meters per second. Stationary, 4 kilograms. That's the before, and then the after on the other side of the dotted lines. The two join together and our unknown velocity v. So total momentum before is equal to the total momentum after. m1 v1 plus m2 v2 is equal to m1 plus m2 times v3. 4 times 3 plus 4 times 0 is equal to 8 times v. It's important that you put brackets on to make sure that you add up the numbers correctly. So on the left hand side we've got 12 plus 0 and on the right we've got 8v. And this means that v is equal to 12 divided by 8, which is 1.5 meters per second to the right, because it's a positive number. So the direction is that anything right is going to be positive. Second example, car of mass 1000 kilograms is traveling at 5 meters per second. It collides and joins with a 1200 kilogram car traveling at 3 meters per second. Calculate the velocity of the cars just after impact. So draw a picture. There's the first object, there's the second object, What's it look like after the join together with our unknown velocity? Total momentum before is equal to total momentum after. M1 V1 plus M2 V2, that's the momentum before, is the total mass M1 plus M2 times V3. Substituting our numbers, 1000 times 5 plus 1200 times 3 equals 1200 times V. Work out our numbers, solve to get our answer plus our unit. So V is 8,600 divided by 2,200, which gives us 3.9 meters per second, positive to the right. So what did you need to know? You needed to know what momentum was, the mass times the velocity. You need to know how it compares before and after, so the momentum before is equal to the momentum after, provided there are no external forces, and you need to be able to solve problems for situations where there are collisions and the objects move off together.